Okay, so we have a problem here. We're jumping onto chapter 26. So this one we're given um a, I would say it's not that complicated of a circuit, but it requires a lot of thinking. Right. So we're given this circuit where 5 amps is flowing down here, and then we have an unknown voltage source in the middle. We're given a resistor with this voltage source. And then at the top here, we have two unknown resistors. Then we have a 20 ohm resistor, 30 ohm resistor, an 18 ohm resistor with this 20-volt battery, and we're given this 200-volt battery. So in the equation, I'm actually not given a direction for the batteries, but we are given a direction for the currents. So if we look at this junction over here, if we look at that junction, we're given um we're gonna go ahead and just write it out. We're gonna go ahead and write it out over here. I think I could write all the way over here. Yeah, I could. Cool. Okay, so we're given this junction right here. But this is I1, this is I2, and this is I3. We have our I1. Actually, we can just write I3 or I2 is equal to I1 minus I3. Right? Simple. Or we can say that I1 is equal to, sorry, you probably can't see this. So we'll just do it like this. I1 is equal to I2 plus I3. Cool. So we can actually find I2. We can actually find the current going through this middle wire because we are given. Oh, I think we're given. Oh, cool. Okay, so we are given the voltage across this 8 ohm resistor. So we have VAB is equal to, or not even VAB. We're just gonna go VR is equal to 16 volts. So since we're given the voltage through this resistor and we have the value of the resistor, we can find I2. So our I2 would just be from Ohm's law. I is just equal to the voltage over the resistance. For this instance, it's going to be 16 volts over 8 ohms, which gives us 2 amps. So we can go ahead and just write it over here. If our I1 is known, our I2 is known, we don't have an I3. So we can just solve I3 by doing I1 minus I2. And I3 would be 5 amps minus 2 amps is just 3 amps. Our I2 is equal to I2 is equal to 2 amps. And our I1 is equal to 5 amps. Cool. We can go ahead and just erase this. So now we have the currents going through this way. So we have the currents I1 and then I2 is the middle, I3. And we or I notice that these two resistors are in a parallel and these two resistors are in a parallel. So we can actually just rewrite this or redraw the circuits as just one wire going this way if we find the R equivalents for these four resistors. So we're gonna go ahead and just do this top one. So this top one is giving 20. So this is in the parallel. So since it's in the parallel, it's gonna be the R equivalence equal to 1 over 20 plus 1 over 30 to the negative 1. You can't see that. The markers are so bad. 1 over 20 plus 1 over 30 to the negative 1. And if we put this into a calculator, we're given 12 ohms. So we can just replace this with just one 12 ohm resistor. Cool. And then we can find this one. And then we just have 1 over R plus 1 over R is just 2 over R minus 1. So the inverse of that would just be R over 2 or 1/2 of R. Where's this? Cool. So now we're dealing with a much easier circuit here. It's much easier to see. I'm going to just erase these. Much easier to see. And then I'm actually going to do my work in a red mark. Okay, cool. So now we can solve for the EMF of this X here, of this missing battery, battery source, or this voltage source. I'm gonna go ahead and just choose a loop, right? I'm just gonna go ahead and just do this loop. So essentially we have three loops here. We have one loop over here, and then we have another loop over here, and then we have a big loop on the outside. So since we have two unknowns, we need three equations. I think. Let's just work it out. Let's try to find the value of the EMF of this voltage source. So first we're gonna do loop 1. Actually, wait. The amps. Actually, sorry. I should follow the direction of. I should follow the flow of currents here. So this actually is there, lower it there. Okay, there you go. So I'm gonna go ahead and just do 1. So over here we have. So if this is gonna be our positive, we're gonna go for a. We'll say that this is positive. So we'll say 20 volts. We're just using Kirchhoff's loop rule. That is Kirchhoff's junction rule, or junction rule, and this is Kirchhoff's loop. And we're gonna go minus. Oh, actually, we have this thing right here, so we can just go ahead and just do x minus. We have an 8 I2. We have minus 12 I1. And then we have a minus 18 I1 equals 0. So we're given 20 volts minus our I2 is equal to 2 amps. So 8 times 2 is just 16. This is just 16 volts. Minus 12 times 5 is 60 volts. Minus 18 times 5 is 90 volts is equal to x. And then let's go ahead and just do this simple algebra. We have a minus, whoa, okay, wait. So then we would have a minus 50. So minus 40. Okay, so I'm so sorry. Minus 150. Minus 166. We have minus 146 volts equals, it should be x. So it's minus 146 volts, which is weird. Actually, it's not weird. That means that our battery is going the opposite way of the current. So basically, it's what it's saying. Wait a second. Actually, we have a negative voltage drop here. So instead of this, there should be a negative. Okay, cool. That should be a negative. I think. Yeah. Okay. Yeah. So this should be a negative. It should be 186. 186 volts. Sorry. Negative 186 volts. That means that it's going against the currents. So the EMF of X is going to be 186 volts. So if we have a voltage drop of a plus and a minus here, right? Since it's going this way, it would be also a plus and a minus here. So we could say it's going to be negative 186 volts in the negative direction. So it's this way. Yes, okay, so it's this way because it's going against the current. It's getting pushed this way. Cool, okay. So now we have the EMF of X. We actually have we have the currents flowing through the 200 volts. It's going to be I3, so we have a 3 amps over here. So now find the value of our resistors. Cool. So this one is also probably just very simple. We're just gonna do another loop. It's gonna be the loop 2 right here. So we actually don't need. So we have two ways of solving this. We have one big one, or we can just do this small one right here. Maybe we could try doing both and see what answers we get. Since this current is just flowing in one direction, this current is flowing in this direction, but it's also flowing this direction from the middle. So it's flowing this way, but it's also flowing this way. So the middle flows against the current, basically. Right. So if we go from positive here to negative, we're going to have a positive voltage drop. So we're going to get 200 volts. And then we're going to have a minus 1/2 R. And then since this is going against it, since the current is going that way, and our direction is flowing this way, it's going to be a minus times a minus 8 ohms times 2. Actually, our voltage is already right here, so it's 16. So it's going to be 16 volts. So it's going to be minus times a minus 16 volts. And then we have our X here. It's negative 186. And then it's just equal to 0. Cool. So then we have a 200 minus 186. We're going to have 14 volts. We're going to go minus 1/2 R plus we have a 16 volts here. And we have 14 plus 16 is just equal 30. And then 30 on the other side. So this is going to leave us with R over 2 equals 30 volts. Sorry, 30 ohms. Oh, actually, that is weird. We have 20 volts. 1/2 R. I should have an I3 here, actually. Sorry. Yeah, okay, that's better. I3, 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 which is I3 is 3. So R3 over 2, sorry. Okay, so that way we can just write this into volts. This is in amps, and volts over amps should give us volts over amps should give us ohms. Because V equals IR, R is equal to V over I, volts over amps. Okay, cool. Okay. So we can just solve for R here. 2 times 30 is 60 divided by 3 is 20. So R is equal to 20 ohms. Okay? I feel like the most confusing aspect of this would be trying to find the value of x. And the way that you can do this also would be to find the r first and then do the second loop. But I feel like that should be fine as well. But I found the EMF of x first. Just this, negative 186. So the reason why it's negative 186 here, it's because this is moving in a opposite. Since it's moving in the opposite way, we have a negative voltage drop. And since this is a negative 186 and it's flowing this way, it's going to be a negative times a negative times a negative, which is just negative 186. I think that's going to be the best way to describe loops. Okay, thank you.